to cos 2 pi over 3. And in your unit guide, they might ask you if we wanted to have, well, we're going to stop there. This is the only angle it would be equivalent to if we're just talking from 0 to 2 pi. If they give you the range for your range is 3 pi, you would add another 360 degrees to 120 degrees to get another related angle, or 360 degrees to 240 degrees to get another related angle. Does that kind of make sense to you guys? So you're always trying to use your cast rule to figure out where the related angles are, if that makes sense. So it's all about playing with your special triangles. We're never going to ask you to draw a triangle for 52 degrees or 37 degrees. It's always going to be equivalent to 30, 60, or 45. Of this unit is going to be to convert from radians to degrees. Now, to actually talk about specifically what a radian is, you need this definition. A radian is the angle subtended by an arc and 2 radii. What that means is, if I have from the origin this radius and this radius, and I have a certain measure theta, this is my arc length. So you have an arc and 2 radii. Theta can be calculated as the arc length divided by your radius. That's how theta can be calculated. In the same way, arc length is the same as your theta multiplied by your radius. And your radius is equal to your arc length divided by theta. So you can manipulate the original formula to derive formulas for the other terms. Now, in a general circle, remember that your radius is equal to r, and in a general circle, your arc length is going to be equal to your circumference of your circle, and your circumference is always, the formula is 2 pi r. So those are general qualities of the circle that you should remember. And there are a few questions in your guide where you just have to use this formula to calculate different pieces of information. Now, if we're talking about conversions, so before we get to, this is a word problem, and I'm going to do 2 major word problems with you. So we have to remind yourself a little about conversions in general. So recall that if we were trying to convert between centimeters and millimeters, for example, if I wanted to figure out 23 centimeters is equal to how many millimeters? So this is grade 9 mathematics again. This is how I would do this. 23 centimeters, I would have to figure out, first of all, in 1 centimeter, I know there are 10 millimeters. And we always have to do it this way so that this centimeter and this centimeter would cancel out, and then we can multiply the corresponding numbers. So 23 times 10 would give me 230 millimeters. So you guys all understand basic conversion, right? We use this information to convert radians into degrees. So for example, if I want to figure out 150 degrees is equal to how many radians? Well, I'm going to start with my degree measure. And you're going to multiply, in terms of radians, in 180 degrees is equivalent to pi radians, right? So that's why in order to convert from degrees to radians, we always multiply by pi over 180. Now I know that 150 and 180, we simplify that fraction, it becomes 5 over 6. So this means that 150 degrees is equivalent to 5 pi over 6 radians. Or 5 pi over 6, it's implicit. If we're trying to figure out from radians to degrees, we do the opposite. So if we're trying to figure out 2 radians is equal to how many degrees, I take the number 2 and I'm going to multiply that in pi radians. I have 180 degrees. So that's going to be equivalent to 360 degrees divided by pi. 360 degrees divided by pi. And remember that pi doesn't represent 180 degrees here. Pi represents your button on your calculator, the pi button. Not 3.14. You actually want to use the button to get the exact number. And when you do that, you're going to get 114.6 degrees. If you don't use the pi button, you're not going to get the exact measure of degrees. Does everyone understand that? Very simple. So either pi over 180, 180 over pi. Do not mix it up, because if you mix it up on your test, you're going to get all skewed answers. So I think the most difficult part about Unit 4 are the word problems on angular velocity, because you can kind of figure out the special triangles and the related angles with lots of practice. This is what's giving people problems on the test. So let's copy down the word problems. I want to do 2 word problems with you guys. A Ferris wheel has a diameter of 135 meters and completes 1 rotation in 30 minutes. Determine the angular velocity in radians per second. And after, we have to figure out how far. Now, far is the key word here, because it means that we're trying to calculate distance. How far does the traveler move in 10 minutes? Okay. For angular velocity, it's important that we have to figure out, first of all, we know that, well, first of all, you know there are 30 minutes. Okay, sorry. Let's start again. From the question, we know that 1 rotation is going to take 30 minutes. That we know. To do a little conversion on the side, because we're trying to figure out in radians per second, we need to convert that 30 minutes in 1 minute. I know I have 60 seconds. So the minutes cancel out, and 30 times 60 is going to give me 1,800 seconds. Does everyone agree with that? 1,800 seconds. So that means in 1 rotation, how many radians are there in 1 rotation? From 0 to 360, that's equivalent to the circumference of a circle, which is 2 pi. 2 pi radians in 1 rotation. And in 30 minutes, we have 1,800 seconds. So this is what we're looking for, angular velocity in radians per second.